On to number 7. Number 7 reads, for the following 4 reactions, identify the type, predict the products, and make sure the formulas are correct, and balance the equation. Now, for A, I notice I have monatomic, okay, just element, and then I have something that's binary. So this is going to be single displacement. You can say replacement, that's fine. They're the exact same thing. Now, we're going to have a situation where chlorine may or may not replace iodine. This is up to the activity series. Looking at the periodic table, chlorine is above iodine in the periodic table in its group. So yeah, chlorine is successfully going to replace iodine. It's not going to replace sodium, because then you just have 2 negative ions together, and guess what? Negative ions don't go together. So they only replace like or similar elements. So we're going to have chlorine aqueous plus NaI aqueous, and we're going to have reaction arrow. We're going to have iodine by itself now, and then NaCl. Now these are all going to be in the aqueous stage, right? Most single displacement reactions happen in solution, so when in doubt, put them in the aqueous state. Now I need to make sure that these things are balanced. So you got 2 chlorines over here, only 2 over there. Well, I better throw 2 over there. Well, that means I have 2 sodiums, so I need to put 2 sodiums over here. That means I have 2 iodines. Oh, I have 2 iodines right there. Okay, so we are balanced. We have 1 chlorine, 2 NaIs, reactive form, 1 I2, and 2 NaCl's. All right, looking at B, I have 2 simple, I have an element and then a simple compound. This is, right, it's 2 elements. It's 2 atoms, but it's 1 element. So this is, something that is considered pretty simple. So this is going to be a synthesis reaction. Remember, a synthesis reaction is taking place when you're combining 2 simple substances. So we're going to have magnesium, and it's a solid. Nitrogen's a gas. And they're coming together. So we're going to go MgN. But these are going to be ionic, right? This is a metal, and nitrogen's a non-metal, so we need to make sure that we're balanced up. Magnesium, being in main group 2, is going to form a +2 charge. Nitrogen is going to form -3 charge. So we're going to cross those charges, cross them down. We're going to have Mg3N2, and that'll be a solid. If you're not really sure how to determine whether or not this is a solid right now, that's fine. The solubility rules, we're not going over that right now, so don't sweat. If you put AQ, that's fine for right now. I'm more concerned with whether or not you predicted this Mg3N2. All right, looking at C. The first thing I notice about C is I have 2 substances. Both are binary. Both are binary. And so that's going to make it a double displacement. So we have the cobalt nitrate and aqueous reacting with H2S, aqueous reacting to form. Now, what's going to happen is cobalt going to replace hydrogen? Yes, it is. Okay, yes, it is. Hydrogen's way down there on the activity series, especially when compared to a metal. And I know you're saying hydrogen's not a metal. Yes, but compared to sulfur, hydrogen's very metallic. And so in this situation, notice that it's in front, like a cation would be. Cobalt is going to be replacing the hydrogen. So we'll have CO. What the heck? Get rid of that. COS. There we go. Sorry. So it's COS, and then it's in the solid state. We're gonna have the hydrogen take over where that cobalt was. Sorry if that looks a little janky. Make sure that these things are balanced. Oh, sorry, I already wrote down the balanced version. 2 right there makes it balanced. We're all honky-dory. Let's look at D. Something reacting with oxygen. Combustion. Easy. The next question is it something other than a hydrocarbon? No, it's a hydrocarbon. Hydrocarbon. And so this is going to have both carbon dioxide and water as its products. So let's go here. C2H5OH in the aqueous. Plus O2, the gas, reacting to form. And so we're going to have CO2 and water. How do I know that? Because this is a hydrocarbon. If it was only carbon there, I would have only carbon dioxide as a product. If it was only something that had hydrogen there, I would have only water in the products. But it's got both hydrogen and carbon, so my products need to have both hydrogen and carbon as well. Didn't write the states. Liquid water. All right, now let's balance this bad boy up. So I got 2 carbons over here, only 1 over there. So I'll try to put a 2 in front of there. So I have 6 oxygens. I only have 1 over here. No, I got 3 over here. What have I got? 5 over here. So let's see if I go 3, 7, and 1. Make that. That'd be 7. Okay, so I got 7 oxygens on both sides. Hydrogens are looking good. All right, so that's your balanced chemical equation. So the main thing here, hopefully you guys can already balance your equations where you're at. The main thing I want to draw your attention to here is the method with which I identified what type of a reaction was taking place. I looked at, simple, binary. A simple and a binary indicates a single displacement. 2 simples indicate synthesis. 2 binaries indicate double displacement. And then anything reacting with pure oxygen, that's going to be combustion.